Yeah, one stop on our InterGeo tour here in Stuttgart is on the Teledyne booth because they announced a new sensor for drones. And I have on my side Malik, but maybe you introduce yourself and then a little bit to the system.
Sure. Yeah, my name is Malik. I manage sensors at Teledyne Geospatial. Usually I manage bigger sensors for helicopters and planes. But today I'm here to talk about our new introduction, which is Echo 1, which is a 1 kilogram fully integrated payload with LiDAR, INS solution from Inertial Labs, as well as a built-in camera for colorization.
Yeah, and I think we have some specs where we can move here, where we can show a little bit the technical features from the system.
Sure. So the system is rated, we tried to not have any compromises. So we tried to maintain the cost low, but to keep the range long. So it flies up to 270 meters, so quite high for a 1 kilogram system. And then we try to maintain very, very tight accuracy. So
you have these 5 millimeters range.
Exactly.
You can see if you compare to typical sensors what are used in the entry class, like L2 from DJI or like an Hesai, they are like 15 to 20 millimeters.
Indeed.
So, and you are only a quarter of this.
Indeed. So the goal is to really get resolution on hard targets that is quite smooth, natively straight out of the system, so that it can help with modeling of sidewalks and roads and wires and poles.
Yeah, especially like if you, it's maybe not a drone, but if you have like for the clients, if you have a street and then you have the sideboards, and you have a lot of range noise, so the sideboard is not really a sideboard, so you not can make automatic fitting from that.
Right. So this is kind of part of the goal is to maintain long range, but to keep the accuracy quite tight. So you see 5 millimeter range, G-reference accuracy is 1.5 centimeters, so
that's super good.
Quite tight. Yeah, it's also designed for very good canopy penetration, seeing through trees and jungle, up
like
to 8 returns.
I think that's super good.
Yeah, can do 600,000 shots a second. Very, very importantly, you can see here the exit window is a little bit more like a frame because the system doesn't only fire down, it also fires in front of it and behind it.
Okay.
So you get oblique looks on vertical targets.
And you have this, you use like an oscillation mirror for doing this?
No, this is a rotating system.
Rotating, okay.
Yeah, rotating system, and you can get 10 degrees forward look, 10 degrees backward look.
But the customer can decide that these 4 to 10 in the software?
No, these ones are fixed. Yeah,
okay.
Fixed. So you can imagine the benefit for buildings or trees or electric poles where the system is approaching them, and you can fire on the target as you approach it, and skip it, it gets the other side. So it's a very, very high resolution modeling out of the system.
And you had another sheet for the people that with all the technical specs where we can show how many points we have in like this one. You can see here a very good sheet here. Unfortunately, it's going down. So this is with the different pulse rates.
Exactly.
And if you say we want go, what is the you have like forestry and asset modeling. So
for example, if you fly at 120 meters, around 20 meter per second, you can get 100 points per square meter. Which is very, very high resolution for modeling.
For UAV systems. So,
exactly. And if you go lower altitude, say you go 60 meters, you can get 200 points. If you go higher altitude, say you go to 180 meters, you're about 50 points per square meter.
Yeah, but I think there's a limitation for drones. I think 180 or something, it's more or less the lower, like in Europe, the lower point.
Yeah, so here kind of the benefit is if you have the ability to go long range, this system, even though it's a 1 kilogram system, you can go quite long and have quite high resolution.
Okay. And this with this 1 kilogram save also battery time, so that you not lose so many flight time by having a heavy sensor, and also low payload is also good for the government regulations.
Indeed.
Did you can tell anything to the price? Is public the pricing, or it's
reach out? I'll encourage people to reach out.
But I can tell you it's a good prices. So
reach out because this pricing is very, very competitive. This is a Western-made, NDAA compliant, very secure system. And the price is very competitive to the alternatives on the market.
Okay. Thanks.
Super. Thank you. Thank you. Cheers.
So here we are on the X-Grid booth. I'm together. Maybe introduce yourself.
Yeah.
So what is your name and what you're doing in X-Grid?
Yeah, hi, this is Mingdi Li. I'm from X-Grid. I'm in charge of the overseas marketing and very happy to be here with the laser scanning. And it's my honor to be to introduce our scanner and brand.
Yeah.
Thank you.
Your brand coming from you're coming from China, and where you're based there?
Yeah, we come from China and we based mainly in Hong Kong, and we have the factories in Shenzhen.
Okay. And you have two models over. You are now like 5 years old or a little bit older. So the company history is around.
Actually, the team is relatively young. We founded on 2020.
2020, yeah.
But even though the team is young, but we have long experience in 3D reconstruction, because the main team comes from the DJI, and our CEO, Dr. Zhao Kaiyong, is also the first product manager of the DJI Terra.
Okay.
Yeah.
From the Terra software.
Yes.
Okay.
Yes.
And now you bring two systems on the market. Is they both from the same time, or was this system before this system, or?
And this one is launched in last November, and this one we just launched it the day before yesterday. So this is the first day of the Intergeo. We launched our newly production. This one called L2 Pro, which is a new generation of the handheld scanner, and we try to redefine the real-time accuracy and performance of the point cloud data.
I think in this system, this is interesting because we have 4 cameras. This means I think that you use Visual SLAM and 3D SLAM, and this is a very new. So I see this in the market. So maybe you can tell something about this. Why this makes sense for the customer?
Yeah, so I think the biggest difference we've made is that we combine the LiDAR with the Visual SLAM. So the multi-SLAM just make a good complementary with each other, so that make the SLAM scanner or algorithm much more robust and reliable, which compatible for more complex cases.
But did you also make this in this system and the new system, or you use another technology?
Yeah, the algorithm is quite the same, but we try to use make a full use of the LiDAR and the sensor in this one.
Okay.
So this one is much more professional one.
Yeah, because you have these more professional laser. Yeah, this is an entry market laser, and this is like many companies use this kind of laser for. Is it a 32 laser lines?
32 channel, yes. 32
you offer 2 systems, or 16 and 32?
Yes, of course.
So, and what is the Pro? What is the advantage to the previous version? It's
actually we got the L2 Pro. It's really a new one, which redefined the efficiency of which defined the accuracy of the real-time data. We generate color point clouds data. The data quality is quite similar with those processed by others.
Okay.
So you got very amazing point clouds right after your scan. So that's the real time and real SLAM.
Okay.
Yep.
And what I like that, but we can show it in our software, so that you have this presentation for this system, that you can do this mesh presentation with these Gaussian patterns.
Yes.
So that's really amazing.
Yep.
What customer can get out from the system. I think it's no extra software. If somebody buy the system, he can get this stuff, and that's interesting for marketing and movie industry, gaming. So this is very nice. So it's very eye-catching results out from the system. So
yes,
I like this. So
and I think that Gaussian one is really a new technology which compared with the mesh or photogrammetry things. And Gaussian splits itself, I think it's not only a thing for viewing, but also it should be applied in different kinds of industries. Which like in AEC industry, it's not only for virtual tool, but also sections or annotations for collaboration. And
and now you are coming to Europe, so now you are having official importer in Germany and some dealers like we are and some others. So and I think you will be also going in other European states. I think you are also for people from the US. I think in the US you can also buy the system.
Yes.
As now you go because you're a young company. Now you make the international step. So finding local dealers that present the products in different states.
Yes.
Is that the plan? So is this your job to doing so?
Yeah, actually, I think the X-Grid should be an international company. It should not be a Chinese company who do exports. So that's why we try to find more more and more international team, so that we welcome partners and talents from all around the world.
Okay.
And I like the partners like you.
Yeah.
You're so professional and impressive.
Okay, perfect. I think we have it, so. Yeah, interesting. Today we are going on the air. We are here in Quantum System. And for me as German, I like, because Quantum is a German company. But here we have an international English native speaking guest. Maybe you introduce you and the company.
Yeah, Eric, thank you. My name is Nick O'Neely. I'm a regional sales manager for North America for Quantum Systems. As Eric stated, I've been a little bit about me, I've been in the drone industry for 10 years. I've worked for manufacturers, I've done a service provider, and I've worked for a software company within the industry. Been at Quantum Systems almost 2 years now. As Eric said, we are a German-based company. We have 4 offices around the globe in Australia, US, Ukraine, and Germany. Quantum Systems have been making fixed-wing platforms since 2015. Yeah, I think that's a good little background.
And what is the as payload? You can use cameras and LiDAR, or only cameras?
Yeah, so the good thing about Trinity Pro, which you see here on our robotic arm, Trinity Pro is our commercial fixed-wing platform. Some key payloads that we have, we have LiDAR sensors, we have RGB sensors, we have an Altum PT for NDVI, we have an Oblique for big urban 3D mapping type applications, and then our RX-1, our Sony payload,
And the good one is the flight time is approx?
That's it. One of our key strengths in the industry, Eric. We have a long flight time of up to 90 minutes. Now, depending on payloads, that will increase, decrease as your payload selection. But yeah, it's one of our key strengths. Flight time, wind tolerance as well. So that's a big feature.
How the system is landing by, you have an, what you call them, umbrella?
Yeah, there you go. Good question. So it's a VTOL. So it's a vertical takeoff and landing.
Vertical takeoff and landing.
Yeah, so it's kind of like an Osprey helicopter type configuration.
Like this army from the US Army, they have these doing so. I can understand. Yeah. And interesting, this holder is here for the show, but it's not like a presentation arm, a presentation robot. There's a really an idea behind it.
Yeah. So this robotic arm, it's kind of a similar configuration, Eric, that we're going to have for basically like a docking station. So for those out there, using maybe a drone first responder, that is, or any type of takeoff and landing remotely can be done from an operations center with it.
This means like if you are just mentioned you are in Australia, South America.
Sure.
I mean you have your mining customers.
Yeah.
Also they can have this in a housing on the mine.
There you go.
And the mining surveyor sitting maybe in the head office and say 1 time per week or twice per week, the system should be out of the box, scan my mine, give a real update going down, and then
offloading data, changing batteries, even sensors it may be. But yeah, coming in the future, that's something we want to, I think that's a good thing about Quantum. Not only have we released 3 new sensors this year, but building for that next thing the industry wants. And I think with the docking station, that's a key thing we're developing, and good to see on the product roadmap.
Yeah, I think that's interesting. So you need that DJI introduced this stock.
Yeah.
And this is quite successful what they are doing, this idea. Yeah. And it's good that you're adapting this for your, of course you have a much larger system.
That we do.
But that you're also offering this maybe then in the future for your clients. So.
Yeah, well thank you, Eric.
Yeah, it was nice to speak to you.
Yeah, you as well.
And if people like to get more information, they should be out which website they can use?
Yeah, use quantum-systems.com.
Okay.
And then we have local regional reps all throughout the world.
Okay.
Always down, always happy to go in the field and do a demo whenever.
Okay, and where you are based in the US?
I'm in Colorado.
Denver? Or?
Yeah,
also G-Week is
good.
We'll
see you in February.
Yes. Yeah, and now we are on the Nevis booth. I think Nevis really launched something new. I think it's, how long, 1 week or so?
2 weeks ago.
2 weeks ago was the official launch, and now we can see it live here, and where you are. So.
So, hello, I'm Veit from Nevis. Eric, nice to see you again, to meet us here and visit our booth. I'm happy to present you our, as you mentioned, new instrument as part of our LX family. So I think you know about our bigger laser scanners, the VLX2.
I think we have it here, so on the side, if you like to move, there's a little bit.
There's the VLX2, and we also have the VLX3 scanner, and now we have an addition, the MLX, as a small handheld device, we call it. We redefine the handheld laser scanning, and I'm happy to present you some key features. You see, that's the form factor, 3.5 kilo. We have one battery up to 45 minutes with a USB stick to store the raw data. Very present is the LiDAR. We are using the HESA XT LiDAR, similar to the VLX3, with 32 laser beams and around 600,000 laser points per second.
What do you have these additional small cameras? Is this for Visual SLAM or is this for?
Exactly. So since we just have with the miniaturization, we just have one LiDAR sensor, and the SLAM needs to orient completely in the 3D environment, and that's why there could be some blind spots. So, for example, if I tilt it and the LiDAR is scanning the roof and the ceiling, then there's a blind spot for the tracking, and to, let's say, to support the SLAM algorithm, we have introduced, as you correctly mentioned, these two small cameras. That's for visual odometry. That means they are just capturing features based on the camera stream, and this feature extraction or image-based feature extraction just help in combination with the LiDAR the SLAM.
And what is the camera difference from this your kind of smaller devices?
Yep.
This resolution is a little bit lower as in the ADAS system, or it's similar? Or?
Exactly. So we have, since the form factor is a bit smaller, we have used a smaller camera, so the lenses are a bit smaller on the camera itself. So now each lens capturing 12 megapixel per image. With the VLX2 and 3, we have 20 megapixel.
Okay.
Yeah. But when you look at the results, the image quality is nearly comparable.
Yeah, because you, of course, one point you capture, you colorize the point cloud.
Yes.
And there's maybe not so critical, only if you see the panorama image in themselves. So maybe for auto applications, there's a difference.
Yeah, absolutely.
So is the range the same range on the other system, or does it have a lower range?
So the LiDAR range, so physically from the manufacturer, is exactly the same. But what we are doing, so we do not use the complete range of the laser scanner to build the point cloud.
Okay.
So that means we have up to 50-meter range from the trajectory we are using to process the data and to process the point cloud. But since we are coming from the indoor world, and even you're walking outdoor around the building, 50 meter is a distance where you should be close enough to the
50 meter indoor is a big. It's so like my living room.
Okay. Since maybe one important thing what I need to add, since you mentioned the cameras, you see, I mean, when do you want to test it? When you put it in, you will see that now one camera is pointing to you. And that means when you make a panoramic images, that means you will appear in each image, and also you would cover what is behind you.
That's a typical problem of these handheld scanners.
And therefore we have introduced two different panoramic modes. It means when you just make a short press, all cameras are triggered, but the fourth camera is marked as not to be used for the panoramic image. And to avoid that, then later on in the panoramic view, if there's a black patch, we are doing we call it backfilling. That means from the colored point cloud, we project the point, the color information back to the image. That means as a user, you have a more or less complete impression of the 360. And additionally, when you just lift it up,
like this, then you can change the mode.
Then you disappear in the blind spot. You make a long press, and then you will get a full dome 360 image.
Okay, super cool. I think this was the key features, or?
Yes.
Okay. But very good, many detail. I think everybody can now mention how it works. And did you see it as a separate system or in combination with your other system, or where are the users?
So basically, you can do both. So we have a huge interest of existing customers who are using VLX, who see this as an addition, which is basically correct, because since we have one sensor, half the data, it means if you want to get the similar coverage like the VLX, you need to work a bit more. It means you can also put it out, and then like a spray pistol, you can scan the details. Or for maybe also for smaller companies who let's say need an entry level for also
pricing,
for the investment, for the pricing. This could be, let's say, a good baseline to use for let's say smaller projects.
Okay.
I mean, it's not developed for scanning such a huge hall. I mean, you can do this, but it takes longer than a bigger system.
But a bigger system is more point cloud, because I think here we have the problem that you not have enough points on the roof. Regarding to the other system, we have 2 sensors.
Yeah, correct.
So,
okay. Exactly. Yeah.
So, perfect. So, then nice to get this introduction to your new system, and I wish you a lot of success.
Always a pleasure to talk to you.
We are here on the Emlet booth, and Emlet now going also in scanning, so that is interesting for us as a scanning channel. But maybe Igor can tell us something to the new scanning devices with your integration, or how we call it.
Yeah, so we are showing here at Endergeo the solution that we launched together with Pix4D. This is a scanner that uses the LiDAR on the iPhone with the photogrammetry from the camera and our high precision RTK device, the ReachRx. So together this allows you to create very quick models for documentation, and actually anyone can use it in the field. It doesn't require training to do it. It's like making a video, so I just press the button and it starts to scan. And as it is scanning, it is producing this mesh in real time that you can see, but it's also taking pictures. And once I'm done, I can preview the mesh and the positions of the pictures taken. And this can also be uploaded to your Pix4D Matic desktop, but this could be uploaded to the cloud, then processed, and then you arrive
This is a preview what we see here, yeah. As on the screen, if you stop, now we saw a preview.
Yeah.
Then you send it to processing on the cloud, and then it will be more accurate, more a final product.
Yes.
Yeah.
So this is like a preview, and there you get the accurate model that is actually very good.
Yeah, but it's super good. You have to, as user, is super user friendly. Is more scanning for not scanning experts, and with georeferencing. So, what is your part on this product line? This one is scanning. We can do it indoor, of course, without any GPS. Yes. But what is the advantage to have this Emlet integration?
So if you have GPS, this does. So you can think about it as an RTK drone that you have in your hand.
Ah, okay.
So essentially, this is the RTK GPS. This is the camera with the LiDAR, and then this attaches a really precise position to every captured LiDAR sample and every captured picture, and then you can stitch everything together. And actually, it's interesting because this is being used now with drones, because you can have an aerial survey from the drone, and there could be some areas that you cannot access with the drone, like overhang, maybe a roof. And then you can go with this solution and join the 2 scans together.
This is for Pix4D users.
Yes, this is for Pix4D users. You can join the 2 together.
And your one software platform.
Yes.
Yeah, that's super good.
But the big applications where I see the big trend is documentation, scanning trenches, where this could be distributed across an organization, and everybody could use it in the field, and then people in the office can control the uploaded data, the accuracy, measure everything, vectorize. And the advantage here is that I think now there are so many areas where we use a terrestrial laser scanner where it's a bit of an overkill. It's a very expensive piece of equipment, very highly capable, but do you really need that last 5 millimeter?
Yeah, no.
Do you need this really dense point cloud? I think this solution is a good middle ground for documentation. It's not as good. It's not a terrestrial scanner, but also if you drop it, it's not the same price tag.
Yeah. And another one, and another one is I think maybe open scanning for application where it's not scanned in the moment in case of the price of the terrestrial scanner.
Yes.
So I think and scanning a trenches also with a terrestrial scanner is not really practical because you have a lot of shadow, and with you can do it like this.
You can just walk around.
It's more flexible. I think the only one disadvantage is that the echo power from the iPhone is not the same good like from your antenna. So this means usually the people will use it for 10 minutes. This means with one accu load, I don't know, they can use it for a month or something. With the iPhone, I don't know how long you can scan with an iPhone, but usually the people will not scan an hour with an iPhone.
Yeah, of course. This is a solution that you keep this in your truck, you keep this in the cab of an excavator.
Yeah.
This could be plugged in for charging, then you get out, you make a scan of a trench, and you keep going. So this is not, I think the intention of this system is that it's not for the surveyor to use it like 8 hours in a...
No, it's like quick scanning. So.
Yes.
And the RX have a very long battery time. How much?
I know, this is like 16 hours.
Yeah, something so crazy long. So okay. And then you have some other integrations. What you can show a little bit.
So in general, we are showing like a few integrations that we were able to do. One I think that is maybe less noticeable, we'll go to the drone soon, but it's the ArcGIS integration with field maps.
Okay.
So this is the new model of ReachRx, which is now certified for usage with Apple devices. Okay. And it means that it's compatible with the Field Maps app, and this app it connects you
in the data. This is an app for an iPad from ArcGIS.
Yes.
And now they can use your antenna.
Yeah, for centimeter accuracy.
And they have to use it on a pole or
yes, so they would probably...
you have it here.
They would use it like this.
Okay, cool.
But this is quite, I think, disruptive for this application because the price is very good. So you can, this is like a less than $2,000 setup where you can have centimeter accuracy for your GIS tags. So we're seeing very good adoption for this solution now.
Yeah, okay. It's maybe for our point cloud customer not the most important topic, but it's good to mention that it's now able to capture processed data for GIS.
For S3,
But with an Emlet, you know, we're selling these Emlet products, and we have these GIS customers, and of course a lot of other customers too.
Yeah. So. Just wanted to highlight that this is now S3 compatible. Shall we address the orange, the beautiful orange, the pop of color on our booth? We're also working together with Wingtra to make sure we have a seamless workflow between our base station and their drone. Okay. So this is kind of like, I mean, any drone job these days requires some control, like with scanning. Yes, you want to have ground control points, you want to have a base station. So we are kind of working to make sure this workflow with Wingtra is really seamless for our end users. So if you are a Wingtra customer, think about an Emlet RS3, and likewise, like I think Wingtra is a highly capable platform. They're showing here, this is the new payload with 60 megapixel.
Okay, very good
This
camera.
is very, very serious camera. They have a LiDAR payload. So
I think Wingtra is famous in not in Central Europe because of the flight regulation, but I think they have a lot of customer America, South America, Australia.
They're very big in the United States and in Europe. I mean, they're a Swiss company, so.
But in at least in Germany, the flight regulation is super complex. This is a scanning system for large areas.
Yes.
And we have then very often problems that it's not allowed to fly there. Because we are so high, dense, populated area. So
But I saw it flying in Switzerland, and it's a sight to see it. This is just an amazing platform, I think. We have also some news for our Emlet users in terms of the software. I know you covered some of it, but one of the big announcements that we recently made for our customers is so the updates to Emlet Flow. We now support working with LandXML, DTM surfaces. So you can upload on Flow 360 a digital terrain model, walk around the site, see real-time cut fill value for geometry for the DTM. This is going to be a big application for construction for earthworks, and we are expanding the platform and making real-time demos here. So we'll be happy to show some stuff as well.
Is this an offering? Is an iPad, a small one?
Yeah, this is the iPad Mini.
And you can get also the holder. Is also from you?
This is some kind of standard holder. Now we don't make it, but
but you can connect it with your system.
Yeah, you can connect it. And I really love the iPad Mini as a platform because you have a big screen. And it's very snappy and quick.
It's snappy and it's. Even from the price tag is
it's very affordable. And if you think about the price of a controller, iPad is a very good deal.
Cool.
So I'm really a fan of iPads just because of the screen real estate.
You need a good.
It depends on your taste. I think this is the advantage of Emlet, that you can choose. Do you want to go with an iPhone? Do you want to go with an iPad or Android device? We support everything.
This is very good.
It depends on your taste.
I'm happy to be here with Igor, and he present a lot of stuff very quick together. But if you need any information, check out the Emlet website. Contact the local sales office from Germany. Contact us. It was every time a pleasure for me to see you and to you and your booth. And you have a very nice booth this year.
Thanks a lot.
I like the style. Without this collar, I don't. That's not me. I don't like. Only the collar is a little bit not in this very stylish boost what you have here.
Okay, Eric, it was great having you.
So.
Thanks a lot.
Again, we have another topic of mobile scanning, and now we are on the booth from FZD from China, a Chinese producer for mobile scanners and also other devices like GPS, and I think you have also farming control, steering
machine
system,
control, precision agriculture.
Yeah, but you have also now this LAMP topic is very big in your company. So, and where you are, what is your position, and then we speak about the systems.
Yeah, right. So my name is Edward. I'm a field application engineer for the company FJ Dynamics for the geospatial product.
In Europe?
So meaning in Europe. I'm based in Europe, in Romania, in Bucharest, more exactly. So I deal with the geospatial products, meaning the scanner, the SLAM scanners, and then the GNSS receivers. So we have a product line of three SLAM scanners. This is the FJD Trident P1. We also have a S1 and then upcoming S2, which I will tell you the details later. We also have 4 GNSS receivers, but for right now we will focus on the SLAM scanners. So this one has 200,000 points per second, a range up to 50 meters. And you can do all sorts of jobs. So, for example, for architecture, you can do 2D floor plans. You can measure stockpiles. You can measure for surveying. Different in beam, of course.
You can use this for outside, but it should be for the tracking, not more far away at 50 meters.
Yeah.
So that's the limitation. But if you can, with this one, you can walk more, then it's also working.
Exactly.
And then we have, if it's not enough and you need more points outside, larger range, then you can choose to S1.
The S1.
Or the future S2.
The future S2, yeah. So the existing S1 has, we have 2 variants. The first one is the S1, the simple S1, which has 320,000 points per second and a range of 80 meters. And then the S2 Pro has double the points and the same range, let's say. And then for the upcoming S2, for the, let's say, the best S2, we'll have a range up to 300 meters and then also 40,000 points per second. So quite a lot of.
Okay, this is the hardware side, but you have also some in your software. You also now open the opportunity for customers to use your software to process the data.
Exactly. So we have our own software. We developed the software for iPad Pro as well, so you can process the data and get a quick overview of what you scan. So here, for example, are a few blocks. We just walk around the building, and this is what we can get with the iPad Pro. Of course, you can share this. You can make the simple measurements. You can maybe change how you can view the point cloud. We can also create like the video based on the trajectory that we scanned.
It's a very nice feature.
Yeah.
But this is S1 dataset, yeah?
It's a P1 dataset.
It's a P1 dataset.
With a smaller.
Wow.
Yeah.
Yeah, that's good.
Okay. And then we have the full software, let's say on the computer. So it's our full developed software. It's called Trident Model. Yeah, so this is the software on PC. It's also a scan done with the smaller scanner, so the P1. It's a church.
It's also P1 dataset. Okay.
It's also P1 dataset. Yeah. So here the customer can maybe see an example of what they can get with the scanner in terms of a point cloud. We also have, for example, if you want to create 2D floor plans, we also have this option. Let's see. So here we have a 2D floor plan. We create a slice plane, and then we have an automatic function that it's extracting the lines. Exactly. So then you can export this into DXF, for example, and finish the project in AutoCAD, for example. We can also create maybe promotional videos from for different customers or for our own website. For example, we can create a video by frame. Sorry, again, this one. Yeah, so we can create a video for our customer or maybe for promoting on social media. We just add some frames.
some scan positions. So
exactly.
yeah, and then it's automatic.
And then the software creates a video, and we can export this to MP4, and then later on social media.
I think it's good. Or we missed something? No. And let us turn here to the end, so we make here the end cut here. So thanks to the Eduardo for giving us a tour.
Yeah.
So and for if people are interested, they find on your website.
Yeah, FJD website.
Find the dealers.
Exactly.
And somebody from Germany can contact us.
Exactly.
So
yeah. Thank you.
Bye bye.
Bye.
So,
thanks for cleaning the floor.
Yeah, thanks. We are here on the Prosec booth, but maybe I don't use it right.
No, I think I'll give you a quick look. So what we have here is the Profimeter, not a broom or a mop. Here is just one of the units there used from our BWT section. What you're able to do then with this is use it on the floor for to try to identify steel or anything else.
In the floor. So
exactly, but you can also take it out here. I won't do a live demonstration, but you're able to take the unit out and then use it on the wall as well.
Okay.
That's what you have here too.
But that's what's us interesting is underground mapping.
So I'll put this one to the side just for the moment, yeah. And hopefully it's fine. So what we've got here is the GS9000. It's one of our newest models that we have, and it's a multi-channel system here. What you've got is the GX1 antenna.
I have to go to...
yeah, no worries. So what we've got here is the GX1 antenna, so a high frequency antenna in at the moment, and we have the GX2 over there, which is the smaller one, and the lower frequency. And what you're able to do here then is able to connect this up to your iPad, and you just start pushing like this, and it all loads in real time. So I've got a little data set on the app view here. We're able to go in and we're able to see basically a street crossing that we did, and we've got the radargram here on the left hand side and our FreePAT, as you know, on the right hand side.
But where you introduced the system, you come first was this system, we came out.
Well, this one came out in about 2021. So the GS8000, that's our single channel. You see Gorka there just presenting with a customer. So we've got just one channel there with a frequency of 40 megahertz to 3,440 megahertz.
And here we have a
multi-channel. So what you've got here is 50 channels in one on this antenna with 2.5 centimeter spacing. You've got 35 across it, and you've got 15 of the VV ones included.
Okay.
Exactly. So it's cross-polarized. So you only need to go in one direction. There's no need for a grid scan in that sense.
Grid scan. I can go if I like to capture this.
Exactly.
Before I have to go grid size like this, and this. Now I can go only one direction.
Exactly. With the GX, with the high frequency antenna, that is very possible.
And for the other ones, maybe we turn what we see on the wall.
Exactly. Yeah, we'll show you something that we're working on. Exactly. So what we have here is the GM8000. This is a prototype now, just to say. So we actually have the hardware and everything ready to go in Zurich. But just to take you through it, what we have here is just like the GS9000, you have the low frequency and the high frequency antennas, but in this system you have two, so one on each side. Here is the brain of the system, based on a hydraulic system as well. So what you can do when you're going over ramps or anything like that, you're able to go up and down. It works with the system. Here we've an IMU and an RTK included. So when the RTK drops, then you're able then to still within a tunnel or a car park or anything like that, or a park house, you're able to hold on to your geo position there as well. So
okay.
It's really good.
And this is for if you have like streets, large areas.
Exactly.
If it's hand wheeled, but maybe also you can put this on a more off-road car and go over the field. Is that also possible?
Yeah, there's a possibility with that too. I mean, it all comes down to the depth and the soil and everything, but definitely with the lower frequency antenna, you're able to use that in other different projects, not just asphalt or concrete or anything else like that. You're able to use it on a field or maybe sand or anything else like that.
Okay.
All depends on if the vehicle can go there, we can go there.
Okay. And for the people who not really understand now what we try to explain.
Yeah.
I think a picture can say more as 1,000 words. So
exactly, yeah.
That is what Prosek is doing. Yeah, that is basically this system shows very good you mapping the underground, and you're looking for utilities.
Yeah,
but also if you have like bridges, you can also see the steel.
You can see the rebars and everything else like that. So we can even see the different layers within the floor and or within the surface. So that's a bit of a game changer.
And if you have a small size area, then it's more to have the small systems.
Exactly.
And if you have to capture a large area, then take this one. Or if you go on larger areas, then you can use it on the car.
Yeah, and that's exactly it. I mean, you use these for to scan cities or anything. So we're able to measure everywhere. And I think what we have up there, and I think says it all really. So sea below ground.
And the only one what we have to show maybe about the company Prosek is maybe you can talk a little bit to the company.
Yeah, I mean we celebrated our 70th birthday this year, so yeah, we're pushing on. EPR is obviously new in our portfolio, or the bigger systems, but we have also the smaller ones as well, and the smaller GPs, and the we come from the concrete world, and obviously coming from Schmidt hammers and everything back in those days.
Yeah, so Prosek is a Swiss company from Switzerland.
Exactly. Yeah, Swiss company.
Close to Zurich.
As I said, founded in 1954. We're based in Schwetzenbach in Zurich. And yeah, we work with our team also in Singapore as well. So it's a really great company and great time and exciting times for us right now, yeah?
Okay, perfect.
Good.